so looking down at the bottom of page 2, this is where we get into kind of the usefulness of rational exponents. So it's like, all right, they're another way of rewriting roots. 1/3 power is the same as taking the cube root of something. If I wrote this expression in radical form, this would look like the square root of a times what? What's a to the 1/5 power? The 5th root of a. So a to the 1/2 is the square root. A to the 1/5 is the 5th root. Can I multiply those together? They are not like radicands. They don't have the same indices, and we didn't encounter anything like that in the first section of this unit. So radical-wise, we'd be stuck. But if we put that into rational exponents, we can actually use our mad spam rules. So looking at these two bases, I'm multiplying the bases. So what are we going to do with those exponents? We're going to add them. So a to the 1/2 times a to the 1/5 will give me a to the 1/2 plus 1/5 power. Do you think we should leave it like that? Or should we try to simplify it to one fraction? Oh no, it's last unit. Come back to haunt us. If we are adding fractions, what do we have to find? Oh, the LCD. So what is the LCD of those two fractions? 10. So 10 is the least common denominator. So I'm going to multiply this one by 5/5 and this one by 2/2, which will give me a to the 5/10 plus 2/10. So how many tenths is that? 7/10. So a to the 7/10 is our answer. Biggest mistake that I see on these problems is students will forget to write the a. They'll just be like, it's fraction time. Oh wait, there's a base attached to it. So don't forget to write a to the 7/10. So that's kind of interesting. Radical wise, when I multiply these, we end up getting the a to the 7th power and the 10th root of it. So do we see why going from this to this is pretty strange? But in rational exponent form, it does make a lot more sense. And, oh yeah, we're just going to add the exponents together. Good old math spam coming back for us. So radical form is not friendly when we have different indices. Rational fractional form is. And I know we don't like showing that creative form of one word, but that's going to keep us fresh on this fraction stuff so that we can stay on top of it, so we can take a good term test over it after break. So let's go ahead and take a look at our next one. Here, what's going on between these two bases? What operation? Division. So we're dividing the bases, so we will subtract the exponents. So I will have x to the 5/2 minus 1/4. What is my least common denominator for those two fractions? A lot of people in the last test said 8, but can we use something smaller? It's 4. So I can just multiply this one by 2/2, which will give us x to the 10/4 minus 1/4. So if I have 10/4 and I subtract 1/4, how many fourths is that? 9/4. So x to the 9/4. What about on this last one? C. What's our base operation here? We are powering up. So when I power up, what do we do with the exponents? We multiply them. So 1/2 times 3 over 1. When I asked third block, I'm like, how do we multiply fractions, guys? They're like, you just do it, which I mean is pretty much it. You go straight across, just multiply them. So 1 times 3 is 3. 2 times 1 is 2. But why is my answer not 3/2? What do we need with it? The Q. Gotta have the base that has that rational fractional exponent. So don't forget, after you do those fraction operations, to include the base that goes with it. So Q to the 3/2. So folks, that is it for notes. We're going to do a couple of problems in the homework packet together. And then we'll take a little walk outside. And then you'll have more work time. So in the homework packet, going back there, again, a reminder, we're not doing 23 and 27 at all. But you should be able to do this whole block, and the bottom 8 problems. The bottom 8 problems. Now, on these ones, you must show your fraction work. Evil face. So you got to show your fraction work, so finding common denominators, creative forms of 1, but only where necessary. Like on number 35, do I need to show any work there? X to the 1/7 raised to the 2. We are powering up. Just multiply those together, and bam, 2 7s. We're done. So some problems might require some work. Other problems, maybe not. So I want you to get as far as you can on number 33 in 1 minute. So what operation is going on between those bases? Dividing. So Matt Spam says when we divide, we subtract the exponents. So x, don't forget the base, to the 2/3 minus 1/4. What are we going to use for our least common denominator here, folks? 12. So multiply this one by 4 over 4, this one by 3 over 3, and we get x to the 8/12 minus 3/12. 8/12 minus 3/12. So I should probably zoom in a little bit. Whoa. Major zoom issue. There we go. We get x to the 5/12. And that is our final rational fractional answer. Any questions?